But oh well. Got like 3 people watching them and stuff like that. It's fine. Alright. I'm gonna go ahead and give you the answer key right off the bat, so you can see, you can compare, you can ask a little more specific questions.
I do have questions on the calendar. The calendar.
It doesn't mean you have to, if I don't say correct it or redo it or whatever, that means you get credit for it.
I thought maybe you lost your.
Oh no, I just didn't say anything. I was like, how much longer? He knows everything. Turns out Mother actually listens in class. That's why he was
No. Everyone had to.
And it was their birthday. He's making his way through the boat.
Yeah. Yeah, see? I like it. That's what I had.
It was like the best part.
2 weeks ago?
I dropped like just like screw this.
So slow.
It's
just so round.
unless they found something like
So guys, we didn't make it to section 13.4, so the funny thing is the 2 I gave you that were triple integrals. Oh, blank one? Or
Yeah, blank.
blank?
I don't know if I know the difference.
Number 8, number 9. And number 8, you don't actually have to use triple integrals for it, but I just, for some reason I did when I did the answer key. And number 9, it says to use triple integrals, but there's an example just like it, and on the answer key I'll refer you back to the page, using double intervals only. Page 890. So there's a nice analogy between, if I want to find the area of something in the XY plane, I can use double intervals to do it, right? I just assume the height is going to be what? What's Z going to be?
0.
If it was 0, then that would be nothing.
Just
1, right? Because then I am finding a volume, but it's still an area. So I can use double integrals to find something I can normally find with single. The same way I can use triple integrals to find something I can normally find with double. There's a nice analogy there. So if you did number 8 a different way, hopefully it kind of matches up with the way I did it. And it's just one step away from doing double integrals. Let's see. So are there any specific questions about practice test problems, homework stuff?
I have like
okay.
So 13.1, problem 30.
I have one from 13.0.
All right. You guys are going in order. I love it. 13, what number? 30?
So I guess I feel better.
This is section.
Yeah, that's the ones that
13, what number 30?
8.
Oh, okay.
Oh, yeah.
So they want you to evaluate these using symmetry to make it different limits. So the region they're doing this around over is negative a to a, negative b to b. what do you think might happen here? I mean, if I let x go from negative a to a, what's special about this function by itself, for example? Special about e to the negative x squared plus y, e to the whatever.
Hard to integrate.
I like it. But e to the negative x squared plus y squared. I mean, how is this, let's just look at a piece of that at a time. E to the negative x squared. What's true about that function symmetrically, symmetry-wise? I mean, what kind of symmetry would this have? And the way you think about symmetry is, if I plug in something and I plug in the negative of that something, what do I get? Are they related, what I get? And of course, if you plug in an x value, plug in a negative x value, you're going to get the same damn thing, right?
Yeah.
If I plug in positive or negative value here, it's going to come, they're both going to come out to be this. True? So both of those inputs have that output. So what kind of symmetry does this have related to the x variable? And this is kind of taking it back to what we're used to. So e to the negative x squared will look like this somehow, like going through 1. Right, almost like a parabola, but not really. All right, you guys love that example. But it's something you should be familiar with from just straight up calculus. The problem with that is they have the x and the y at the same time, but the double integral allows me to do what? I mean, this inner integral will be with respect to one single variable at a time. So I can treat the other variable as a constant at that point. So I can truly just look at it as a function of x by itself. And it is symmetric. If it was in 2D, it would be symmetric with respect to the y-axis. It would be even, right? Even symmetry. All right, and so a good question then would be, how does that help me with anything? Well, that's that function by itself, right? So this function here is even. What's true about the x function? What's true about x by itself? What type of symmetry does that have? And this might be too long ago, maybe. You guys don't use symmetry often enough. There was even symmetry, which is called even because it looks like x squared, x to the 4th power. They have even powers, polynomials, right? Odd symmetry would be that, and of course y equals x has the most simple odd symmetry there is, right? Okay, so think about it. Let me see if I can get you guys with me. If I were to integrate this from negative a to a, what would I get? I get 0, right? Of course I would. Because back here it's negative and up here it's positive. So think about what happens when I take x times e to the negative x squared.
0 times something. Also 0.
What's an odd times an even? Odd. So I always remember like odd is like negative and even is like positive. So odd times even is odd, like negative times positive is negative. Think about this. I mean, x goes negative here, right? What does e do? And now you see why I think of it that way. What does e always, outputs for this is always positive. True? So below 0, this whole thing is negative, and above 0, this whole thing is positive. Right? Because this piece is always positive. So what's the sign of the whole thing determined by this dude? So it is just like negative times positive is negative, odd times even is odd. So when I integrate this from negative a to a, what would I get? 0, because then the negative a to 0 part is negative this, and the 0 to a part is positive that, right? So those two areas would cancel. This should sound very familiar. I mean, this is why if you want true area, you have to be careful about where it crosses the x-axis. Do you remember doing that kind of stuff? This isn't what we call true area because this is negative area. Personally, I hated that. I'm like, well, it's area. It's negative. Who cares? It's still negative. It just means it's down below the ground. Who cares? Okay, maybe not. So what is it about this? It must be the double integration that's freaking people out. But the double integration is just... And what's nice about this? We're in section 13.1, so that's rectangular regions. Which way do I have to do this?
Doesn't matter.
Doesn't matter. Whatever way I want to. So let me just do this. Because I want to. So what would we just say this is going to be?
0.
Yeah, because y is a constant, right? Y is a constant. If y is 0, it's 0. If y is negative, then it's just going to flip this on its head. It's still going to have a negative piece and a positive piece as they go from negative a to a. And if y is positive, then the argument still applies, doesn't it?
So we don't have to actually integrate.
That's the whole point. That's why they didn't give me, they just told me that they're symmetric about the origin, negative a to a. Then I can use arguments of symmetry to see, is it twice something or is it 0? Right, that whole thing. Y'all are used to like doing the twice thing. You can cut it in half if it's symmetric. Why would you integrate from here to here? You can just integrate from here to here and double it, right? That kind of thing. You do that a lot with polar intervals too, right? These big ass things, you know, like, let me just do a quarter of it and multiply by 4 because it's the same thing in all the quadrants. Who cares? This one is nice because it's got odd symmetry. That means it's going to integrate to be 0. Okay. So what does that mean that this surface must do in relation to the xy plane? Let me see if I've gone too far here now. What's this function do with respect to the x-axis? It goes through it, right? So that has some negative and some positive. So what's this do with respect to the xy plane? It goes through it, so it's got some positive volume and some negative volume that ends up canceling out. Cool. So if you want to, you can say it's not really volume, Jeff, it's negative. I don't know, but whatever. This means it's below. You're filling in the basement, right? You tip over this mountain into the basement, fills it in. You got nothing left. 0. And you can do a similar thing with part B. What kind of function is sine? Is it odd or even?
Odd.
Odd, right? Because cosine is even, symmetric around the y-axis. Sine is odd because it looks like a cubic right there going through the origin, right? So sine is odd. What about the bottom there?
Looks even.
Page is up.
This is page 884. Yeah, so that's definitely going to be even on the bottom, right? It's like x squared plus y squared plus x to the 0. If you want it to. That's definitely even. So what do you think odd divided by even is? If odd is like negative, even is like positive.
Negative.
Odd divided by even is odd. I love it. So you have the same argument you can apply here that you did to part A. Cool. You guys loved that problem, I could tell. Make them all like that, Jeff. Yes, I will.
Just don't put these on the test. That's good.
15.2. 46.
46. Oh.
What? 46 or 46?
Especially before I do the homework.
They ask you to change the limits of integration on this guy. Is it e to the what? Y. Okay. So, in order to make the transition like we're going to have to after this test to triple integrals, we really have to be really comfortable with this kind of problem. Because once we bring in the third dimension, and I've got more to worry about at once, I hope this one's easy because that one's going to have extra stuff to worry about. So on this one, what I always try to do for myself, and you guys don't have to do this, I kind of hate the limits thing. I like to go directly. What is x doing? Yeah, it goes from 1 to e to the y. And what's y doing? 0 to 1. So I know y goes from 0 to 1. Yay. That's easy enough. And now x is supposed to go from 1 to e to the y, right? And where is e to the y? And now you got to kind of plot that sucker up here.
Is that gonna be like e to the x or ln x? I was just.
Ah, so now you say to yourself, okay, x equals 1, x equals e to the y. That's what you really have here, right? And y equals 0 to y equals 1. So in order to turn this around, you need to know what y is doing here. So you do have to solve for y, right? So for this one, what is the function here? Y equals natural log of x. Cool. Right?
But that's gonna be limit of integration when we switch them.
Exactly. So right now I want to be able to draw it the way it's given to me.
How would you draw e to the y?
How would you draw it to the y?
Just e like a e to the x?
No, because it's got to be in relation to the y, right? Y is my inputs now for this.
Or it's gonna look like ln x.
So what's y allowed to do? Go from 0 to 1, right? So at 0, what's e to the y? 1. Right, your inputs are y's, your outputs are x's now, right? And at 1, what's e to the y?
2 point something.
Yeah, it's e, right? So it's going to be, at 1, it's going to be, here's 2. So 2 point blah, so it's going to be right there.
So it behaves like ln x.
And if you look at it
Looks like
the
ln.
right way, it's going to go through it like that, right? And of course, you can think about it. You know it's going to be natural log of x anyway. You could have just plotted it like a natural log. But it's easier because they give me what y does. I can use those as inputs to see where it goes from to. That is a natural log piece, right? Natural log would go. You guys see that? So where's my region then? As y goes from 0 to 1, x goes from 1 to e to the y. Where's x equal 1? X equal 1 is here. So x has to go from 1 to this. Good, there it is. It goes from 1 to that. You guys see that? So as y goes from 0 to 1, x must start at 1 and go to this graph. So you don't have to graph just the part of it. You don't have to be that. You can just go ahead and graph the whole damn thing and then go from 0 to 1 in between 0 and 1. From 1 to the function, right? You don't have to know how much of it you have to graph. You can graph the whole damn thing. And then say, okay, at 0 it's 1, and then it has to go from 1 to the graph, and here's the graph. So it's at 1, it's got to go there, and that's the top of it. So I'm talking about this region right there. Okay, how's that? I mean, that's step number 1 is just to be able to take the limits and graph what it looks like. Now, can you turn them around? If I try to turn this thing around, here's my region. My region can't change. Just the way I describe my region can change. So now who's going to be going pure numbers? Yeah, so x is going to go from what to what? 1 to e to the 1, right? So 1 to e. And what's y going to do now? As x goes from 1 to e, be careful now. I want this in here, right? So where's my y start? Give me some x. Here's an x. Where's the y got to start? Can it start at 0? Does it start at 0?
Starts at 1.
Starts at that. And what is that? Natural log. All right, well, let me stop right there because that's the key step right there. When you graph your region from the given, you shade it in so you know exactly what you're talking about. Because if you're not careful, you're going to go get the other piece. I don't want that shit. I want that shit. So I got to start from this side and go to that side. So the smallest y can be for any given x is on that line, on that curve, up to 1, no matter where I am. So some other given x, just to kind of check it, it starts at that line and it goes up to 1. Do you see that? For any x in what x can do, what can y do? What can y do? It can go from this line up to 1. That's what y is allowed to do. Exactly. Yeah.
You can do 1 minus ln of x, right? You can go 1 minus ln of x. You can
Now
start
you're
at the
thinking
top.
about how to get this area here, but be careful. Does this problem have anything to do with this area? Truly, directly, the area, does it have anything to do with the area of this shape? Does this problem, this is a weird question, I know, because this is the hardest thing to keep in your mind. I don't care how much I say it. What's the whole purpose of this region? Which when you're sitting there as a student, you're like, I don't even know how to answer that. What the hell does that mean about me? It doesn't mean much because it's a weird question to ask, but it's central to the whole idea. What is it about that region that's so special about this problem?
The area?
No. Those are all the points that will be my inputs for this function, right? So when I got Calc 1, and I want to integrate some function from 1 to 7, right, so it does whatever it wants to do. Does this distance have anything to do with anything? No. Doesn't that just show me all the points that I'm allowed to use to get my heights, right? You guys with me? So this area has nothing to do with anything really, not directly. It's just the points I'm allowed to plug into this function to see how far up I am, right? Here's the function. Wow. And what am I doing? I'm going to integrate over this. I'm going to get all these little tiny volumes times the height times the height. These are all the points that I'm allowed to plug into this thing. Now, if you can make that step, you'll be so ahead of the game. In Calc 1, it's just a single line. Just single numbers that I'm using as inputs. So when they give me my limits, what do those limits mean? Those are all the x values I'm allowed to use. What does this region mean? Those are all the x comma y values, all the points I'm allowed to use. That's all it means. That's it. Now, if I wanted the area, what would I integrate? What function would I integrate? I'm always hopeful. What function would I integrate if I wanted the area of this? I would integrate the function 1. Z equals to 1, right? Isn't that what we talked about the other day? So, and this is, I don't blame you too much, because this is the weird part about this, but it's not that hard. I just got to somehow make you click. This here just tells me the inputs for the function that I'm curious about, right? I want to know how high up that function is so I can see what the total area is under that function. How do I figure out how high it is? I plug these points in. This is just the same thing. These points are the ones I'm allowed to use in my function. They're going to tell me how high I am at any given point. Which, of course, if I'm higher or lower, it'll be more or less volume. Right? So that's all this region is points I'm allowed to use in this function. I want to integrate. What's this function do? It can do all this weird shit, and I just want the volume right here. Over this, how high up is it? What's that volume? That's what I want.
So what dictates the height again?
Say again?
What dictates the height? In order to find
What dictates the height? What dictates the height here?
function?
Yeah, the function right here. What's this? This will be, if this is x1, this is going to be f of x1. Right?
Yeah.
That'll be f of x1. That's the height. So what's the height at this point here? x1, y1.
It's the
F of x1, y1.
Yeah, it's f of x1, y1. Right? That's the height there.
Because when you said how we calculate the area, and z equal 1, why do we make it?
Exactly. What did we say last time? This is the weird thing. If I integrate z equal to 1, I do end up with a volume, right? That's the whole idea, is I end up with a volume between this and this. Here's z equal to 1. Cool? There's z equal to 1. End up with a volume. It doesn't have the right units. We don't care about units. We put the units on that we want. Mathematically, does it come out to the right answer? Because if I get the area times 1, it's the stupid area, right? So if I did want the area of this region, and I wanted for some reason to use double integrals, for example, my teacher said I have to, then you would integrate the function 1. Numerically, it'll come out to the area. If you want to be a dork about it, you say, well, the units are wrong. Screw you. Let's just make it not a cube, but square. There, leave me alone, right? We do that all the time in math. We do that. I was trying to make the analogy, and you're not all comfortable with this either, so it's not the greatest analogy, but we pretend like we're in 4 dimensions and we really only do 3-dimensional work. Because it's easier. We can use the gradient. It has meaning in 4 dimensions, but we don't care. We just want it for the 3-dimensional piece. So, yeah, I'm going up a dimension for what I need. Who cares? The number comes out the same. Right? So in general, what are we getting for any function you want to put in there? When you integrate this, you're going to get the volume between this and these set of points. Right? And the set of points tells you how high it is. And it's really exactly the same as this really silly thing here. How high is it times how much you move, that's the area, right? How high it is times how much you move, this little areas, is going to be the volume now, right? Okay. Hopeful. This is exciting. Let's do another one of those kind. Let's do another one. Maybe they didn't have to be homework. Let's do 47. That looks freaky.
Never do this again.
Okay. So if I'm you, if I hit something like this and there's a piece of this that I don't really remember, I'm going to take a second. I'm going to make that x for right now. And what does the inverse cosine look like?
Like use.
Yeah, because if you remember, cosine looks like this here. And so to make it 1-to-1, and again, I'm getting a little bit beyond, but this is what the inverse trig functions do. To have an inverse, you have to be 1-to-1. Remember that? To be 1-to-1, you have to pass the horizontal line test. So they restrict the domain to 0. And this, of course, I got to kill 0 to pi, right? And so it's going to lay that inverted. So what's that going to look like then? So if I invert it around this line here, or you can put stuff in, I get an output of 1 for an input of 0. You can make a little table if you want to. Whatever you guys got to do. Or you can just plug it in your calculator. You have an inverse cosine function on your calculator, so you can just plug it in and see what the graph is, right? So for an input of 0, I get 1. So for this guy, input of 1, I get 0. Right, so that's just going to pop around that corner there, right? For an input of pi over 2, I get 0. So for an input of 0, I get pi over 2. And for input of, what is that trying to say over there? Pi, I get -1. So for an input of -1, I get pi. So here's what it looks like there. Which is just that flipped around the y equals x line. I think my y equals x line is a little off, but too bad for me. Okay, maybe. So input of -1 gives me pi, input of 0 gives me pi over 2, input of 1 gives me 0. So now coming back up to here, what's doing what here? What's y doing? 0 to 1. And what's x doing? 0 to inverse cosine of y. Okay. Now, of course, the inverse cosine of y is here's the inverse cosine of x. I need the inverse cosine of y. So here's my y is going from 0 to 1. X is going from 0 to the inverse cosine of y. So for y equal to 0, what's x going to be? What's the inverse cosine of 0?
0 or pi? Oh, no, 0.
Pi over 2.
Yeah, exactly. So remember, when you think about inverse trig functions, you think about what angle would give me what's inside. So the inverse cosine of 0 is going to be pi over 2 because that's the angle that would give me 0, right? So if y is 0, x is going to be pi over 2. Let me see how I'm going to do this. Let me do 1, 2. So pi over 2 is 1.57 something or other. And if y is 1, what's the inverse cosine of 1? 0, cool. So if y is 1, x is 0. Okay, sort of maybe. And this again, let me put this down here, this is pi over 2. So like, for example, pi over 4, just kind of put something in the middle here. Pi over 4, what would the inverse cosine of what would be pi over 4? What's the cosine of pi over 4?
1 over square root.
1 over square root of 2, which is 0.7 something? Something like that? Okay. So I'm talking about really the region from, you can kind of see it here. I'm talking about this region here, just turned around because this is cosine inverse of x. I want inverse cosine of y. So I'm really talking about this region right there. So as y goes from 0 to 1, x is going from 0 to this function here, right? That's the way they give it to me. So now, this is the region I want. Indicate it however you want to. Let me just put some x's in. I want that region. So let me turn it around. If I turn it around, now x can go from what number to what number? 0 to pi over 2. And what's as x goes from there, what's y doing? It's going from here to there. And if x equals inverse cosine of y, what's y equal to? Cosine x. Cool. So then this would become f. So now we turned it around. It was dx dy, now it's dy dx. Y goes from 0 to cosine x. X goes from 0 to pi over 2. And why is it nice? Think about it. Why is it nice if you flip it around from having an inverse cosine? How easy is it to remember the integral of the inverse trig? Not. Now I've got the integral of a cosine. I can do that. Well, depending on what my f function is, but still. Yeah.
Okay, for the y, after you changed it, why is it from 0 to cosine x, but over here it wasn't?
Exactly, because I want, over here, I didn't want this, did I? I didn't want this region here. I want this region there. So what's the smallest y could be? It has to start here. It can't start there.
But wouldn't you be starting on the y-axis?
No, because I'm not including this here. Are we talking about this problem here now?
Yeah.
So this problem here, the way they gave it to me, it was this region that they were talking about, right?
But
Given
you're still
these
gonna have-
limits.
But you're still going to have your like, your y is 0, you're still going to have a point.
Are you allowed to use y equal to 0?
A lot of times I'm confused.
Yeah, you can use y equal to 0, can't you? So I don't understand. What's the problem?
So
Oh, I see what the
why
problem
would
is.
the reason
Okay,
go-
I got you. All right, now here. Y is the one that, one of them has got to be functional dependence. It's got to start from a function and go to something else. If I just say x goes from 1 to 2 and y goes from 0 to 1, what's wrong with saying that? If I just say x goes from 1 to 2, y goes from 0 to 1, I get the entire rectangle. I don't want that. I want this upper piece of the rectangle, right? So as x goes from 1 to 2, y, for example, right here, if x is 1, what's y going to be?
0.
0. So there's your y equals 0, right?
Yeah.
Y is 0 right there. So x is the one that's allowed to be free. It can go from 1 to 2. Y has got to, in order to get this region here, y has got to start at this and go up from it, right? In order to get this region. It can't just always start at 0 because then you're picking up all this stuff you don't want. I don't want the point, right there.
So why can that one start from 0 and zeros?
Because he starts from this axis, doesn't he? Right, what does this region tell me now? Right here, are you cool with the region we've drawn?
Yes.
Okay, cool. So, with the region I've drawn, if x goes from 0 to pi over 2, and it does, right? What does y have to do? It has to go from this to pick it all up, doesn't it?
That's correct.
There's no question about that. It's got to go from this, I'm sorry, from this to this, yeah, thank you. It's got to go from this to pick up this region, right?
For y's?
Yes.
So it wouldn't be starting at the cosine graph and then it's going up to 1.
That would get,
I'm going from the same way that you went with this one.
alright, that's the problem. You can't generalize what you see from one problem to the next. You've got to draw the region as this describes it. There's the region as this describes it. Then you got to capture the same region, turning things around.
But how do you know where to start?
Once you've drawn this region, it's actually relatively simple. Originally, this says y goes from 0 to 1. And x goes from 1 to e to the y. And you can see that here's 1 to e to the y, right?
Okay, yeah.
Okay. Now, if you turn it around, then you're going to let x be the specific one, 1 to e. Because y was the specific one up there. In order to capture the same region, where does y have to start and end to only capture this region of points? It can start here and go all the way up, can't it?
Yeah.
But then can it still start here and go up? It's got to start here and go up. It's got to start from this. And what is this? Natural law. Yes. Okay, maybe that's a click moment. I mean, it really isn't that hard. It's like I said earlier, it's just got to click. It is not hard. It's just got to click. And I'm hoping that that was a true click and you're just not trying to make me feel better. Oh, and you're thinking in your head, get somebody else was punishing me later. I've done that before, so. Alright. Let's do one more that maybe doesn't have too much inverse trig going on so we can get right to it.
Kind of match on 54.
54.
Yeah.
54?
Yeah.
It's going to involve this.
What, 32?
Cool.
Yeah.
I actually just
No, get the hands like
I didn't know how to because I was going to wait.
So another point I want to make, and this is a point that's another difficult one to get down. The whole thing about the limits and changing the limits, does that have anything to do with the function inside? Not a damn thing. As you can tell from these problems where they don't even tell me what the hell it is inside. I don't care what the hell it is inside. Changing the limits on my region that I'm integrating over is totally independent of what function I'm integrating. Yeah?
8 minus 1.
Is it 8 minus 1?
No, it's 4 minus y.
4 minus 1.
It's 4 minus
I don't
y.
understand why. I have an 8 minus y.
Yeah, that's what then
Oh, okay. So there was another problem earlier that
There's been like 3 or 4 problems, honestly, that were completely different.
I mean, I
3 or
have 8
4
minus
out of
y, and that's...
hundreds.
Yeah, in the
Right?
solution manual, it works with this one.
Yeah, solution manual goes with that one.
Okay, cool. Alright.
Okay, we're good.
So does everybody understand?
Shaded.
It should be 4 minus y, I believe. And I think in some of you guys it says 8 minus y.
If
Okay.
it's 8 minus y, I mean, it's a dead end.
Sure. Alright. So we're still going to do it. There's a few people out there going, no, still do it, please.
No, you wouldn't be able to do it because that's 4, you're going to get a square root 4 minus y. And then when you integrate it, you're going to get squared, so you're going to get 4 minus y, and you're going to cancel those out. With 8 minus y, you can't do
It
that.
doesn't, yeah.
Oh, with 8 minus y, it's...
Yeah,
okay.
That's why
I get it.
So what I think happened is they obviously released some of these things, and then they went, oh shit. Because this has happened before with the proof problem. They said, oh shit, that doesn't really go. Let's redo this.
Okay.
And a few of you guys unfortunately picked up the ones they sent out early.
So is it supposed to be 8 minus y or 4 minus y?
It's supposed to be 4 minus y.
Okay.
Yeah. Alright. So you still want to see this?
Yeah.
What's the region? Just take a second and try to sketch out the region.
And I
Sketch out the region of integration.
You bought it?
I bought this.
I didn't bring mine to school anymore.
You're gonna have to do the top one minus the bottom. Just like, yeah, you can find, just like by the area of two functions. It's the same idea with the volume between two surfaces. You take the top surface minus the bottom surface. Same idea. The, where they meet, does it make sense that that's gonna be the, on the xy plane? So it'd be 50 minus x squared minus y squared minus x squared plus y squared, because that's the bottom line.
No, I got that,
Okay.
because I got the area.
Well, 'cause like mostly, you know, like, so
So
basically,
that's going to be, x squared plus y squared.
Oh, you're down on the intersection, it's on the intersection, so that describes the region that you can integrate over.
Okay,
Right.
so then we're gonna have to do two integrals, we're gonna have to do this
No.
integral and this.
Not really, just do the integral at the top minus the bottom.
Shit, man.
Get it done.
Once you plug them in, they're gonna reduce.
Oh God, I don't even wanna work today.
Alright,
So I'm gonna integrate over this.
so x goes from 0 to 2.
Yes.
That's a nice one to start at. 1, 2. Y has to go from 0, which is the x-axis, right, to 4 minus x squared. And thankfully, 4 minus 2 squared is 0, that's nice, right? And at 0, this is 4. Alright, so there's your region you're talking about here. However you want to do it. So the way they gave it to me was x goes from 0 to 2, y goes from 0 to this. So now turn it around. If this is y equals 4 minus x squared, this is x equal to square root of 4 minus y, and it's the positive one. You know it is because you can see it, right?
This is the area for S. That's the.
So now if you turn it around, how are we doing so far? Good, okay. You look surprised. So now if you turn this around, I want to do dx dy. So now it's y that's allowed to do what he wants to do straight, 0 to 4. And x is the one that's got to make sure that they catch it all. I think the other day I called it like the responsible one. I can't remember if I did or not, but oh. So one of them just go crazy, the other's got to be responsible. So x now is going to go from 0, which is the y-axis, to this, which is square root of 4 minus y. Cool. And then whatever the hell it was. And so your function on the inside doesn't care. Of course it doesn't care, because we only messed with the inputs. We're still going to input all the same points. We're just going to do them in a different order in a way. Alright, that's all that means. Alright, so hopefully that interval is not too evil. Don't make that first step too much. Did you have to actually integrate this?
Yeah.
Okay.
Of course you did.
It makes it so much
No
easier
problem.
with 4 minus 1.
Yes. Alright.
We had like.
Sorry guys. So let me know if you hit a problem like that. It doesn't seem to make any sense. It could be where they corrected their mistake before they stopped the outflow of books. Yeah.
There's a problem
I feel like.
13.328. You could give a hint on that. I just have trouble to find my limits of integration.
So you have to find where that hits the XY plane.
Like I know the bottom is
Circles, all these are constants.
also basically, and that's gonna, the R is gonna be whatever it's
Well, don't make too much out of it.
Times all of
It's an easy thing to say. Real quick, guys, I want to share something with you. I want to give you a little hint on number 28, right?
28, 13.2?
13.3. Now, here's a key question. How do you find the R that we would need for this? Integrate over R. How would you find that? Using pirate calculus, yeah.
Setting z equal to 0.
Beautiful, right? And that's what you see them do all the time in the examples. That if you set z equal to 0, you're going to find out what part of the xy plane, what points actually cause that cone to happen. You find out where it meets the xy plane. So you set z equal to 0, and you just hope and pray. You add the 2 over, multiply this thing up, divide by 2, and you get x squared plus y squared equals 19, equals 9. Yeah, or r equals 3. Because you can pick up the negative side with your theta, right? So this would be r squared equals 9, or r equals 3.
So we're finding
Hold on, it's 19, no, hold on.
like a level curve.
Divided by 2.
Yeah.
Yeah, sorry.
So it's
Divide by
basically,
2.
it's basically that level curve of when z is.
Yeah, it's a level curve because you're setting z equal to 0. And the connection you got to make is when you do that. When you set z equal to 0, so you get the base of that tall ass cone. You're actually getting the region of points that create that whole thing, don't you?
Yeah.
I mean, the actual place where they hit this circle gets those points, but then every point in the middle, the very middle point gets you that tall point up here, doesn't it? And then as you go down, these points give you the points as you come down to it. So these are the points that create that graph. So those are the points I want to integrate over to get the volume of that graph.
And then that's from 0 to 2 pi.
Exactly. To get all the way around that bad boy, that's why you don't have to worry about -3 for r, because the theta 0 to 2 pi is going to pick it up all the way around. So then you're golden. And of course, what's your function going to look like now?
1 plus r.
20 over 1 plus r squared. So now you're going to integrate this. And what do you have to put at the end here?
R times.
I love it. R d theta. R is going to go from 0 to 3. So R is going from 0 to 3, and theta is going to go all the way around. So that way you catch all of the points. Right?
Like we did previously, do we also change limits of integration for polars, or it's always i's and the outer integral and then the r's in the inner integral?
Yeah, normally it's R's in the inner, theta's in the outer, unless you encounter
So we
stranger
usually don't
situations.
change the limits here.
No, we're not gonna mess with that. I think that by itself is enough. Yeah.
And hold on, did you say like it's okay to actually times it by 4 and just go from 0 to pi over 2, or we should just go ahead from 0 to
Yeah, and of course, the, you gotta be careful, the fact that your function that you're integrating is symmetric,
Oh, yeah.
right? This guy would be symmetric. That's what
Yeah,
would
I
tell you you
actually-
can do
I
that.
actually-
Not just the region of integration would be cool.
Okay.
You guys see that? The region is symmetric, right? But, oh, what could be sitting on top of this thing? Blah. So then you can't just break it up if you
Oh,
were.
it's better to just go from 0 to 2 pi over.
It's better just to do that. I don't think it's any easier to go, you know. That's just as easy as any other number that you stick up there, right? Yeah. And that way you won't make a mistake. Or at least not that mistake. Look for a minute at number 10, since we're talking about polar. I'm sorry, I'll come right back to you. Let's do number 10 on the practice test, and then I'll see what you got. I like 10 also because you have to sketch out the region that you're integrating over. And that one's a nifty one. First, take a minute and see if you can sketch out the region that the integration is describing.
Quick question, for the test, is it gonna go to 13.3 or 13.4?
12, 7, to 13, 3.
13.3?
Yeah.
Okay, cool.
So when we did the
Are we
region,
supposed to turn 13.6 now or to the next section?
Who the what?
13.6, do you want to?
13.6?
Yeah,
The extra credit.
next credit.
Oh, the extra credit. Yeah, turn it in on the next test. I'm not even, yeah. Because I will talk about it a little bit when we hit it.
You just bring
13.2 or? What section is that?
This is 13.3 with elements of 13.2 in it because you have to sketch the region first. I think they have a problem like that in here too.
Because I have a feeling I have again different problems. It just gives me R. When I say I remember. 13.3. Yeah,
Pretty sure, yeah, because they switch. Whatever time different Q is now, it's going to be what linear is.
Is that 13.2 or 3?
Both. The first step is sketch what this says. That's 13.2.
Oh,
And then the second step is convert it to polar and integrate it. That's 13.3.
I was just looking for that.
Wait, this is chapter 10, sorry, this is problem 10,
I can
chapter.
find the
Oh,
exact
practice
problem.
test.
No, it's the practice.
Oh, practice.
Should probably just write practice test in there.
Poor Stu, what are you talking about?
It is.
Oh, you're doing Are you love it?
Okay, let's do it.
Are you looking at it? Oh no.
We switched
What kind of function is this right there?
Linear.
It's linear. The slope is square root of 3, right? But it's just a straight line. And so this one tells you that x goes from 0 to 1/2. And while that's doing that, y goes from x root 3 to square root of 1 minus x squared. Now this problem doesn't say you have to change the limits between dx and dy to dy dx or anything. It's just going straight to polar, but I might want to say a word about it here in a minute. So x goes from 0 to 1/2, that's cool. That's 1/2. Y has to go from this straight line up to this, what? What's that?
It's a part of the circle.
Part of a circle, I like it. So what do you have to know first, really, before you can jump into this? If y is supposed to go from this to this,
Plug in your X values and get it.
what's kind of good to know, maybe, or not? It doesn't really matter, I guess, but it's good to know.
It's set them equal to each other.
You can set them equal to each other. I don't really have to because they gave me a definite thing for x. But it's just good to know if when I draw this thing, do they meet again?
Yeah,
And
that's
also-
Yes.
Yeah, right? So if I say x radical 3 equals square root of 1 minus x squared, yeah, so I get 3x squared, so 1 minus x squared, right? 4x squared equals 1, so x squared equals 1/4, so x equals plus or minus 1/2, so it does look like they'll meet at 1/2. Do you see that? And x at negative 1/2, but who cares? That's outside of the part that I'm worried about. So at 1/2, where are these? They both have to be the same, right? That's what we just figured out. So it'd be square root of 3 over 2. What is? How are we doing so far? I mean, is that very semi with me here? So I need to get some boundary points, some anchor points to help graph this. So now I know they meet at 1/2, and that is at square root of 3 over 2. So I know they meet there. It's good to know. What's another good point to know about that so I can draw him?
So linear.
Yeah, going through 0, right? So that one's easy. So that's y equals x radical 3. And then this is a circle that is centered at 0, where the radius is 1. So it's going to be, like here's 1 way out here, so it's going to be e-haw. So I just have to go e and stop.
To Dorito.
Cool, I like it. I always think about it as pie.
Yeah.
I
like Doritos.
All things to think of.
Pizza, something.
I work pizza.
It's the ideal Dorito.
Pizza is just disgusting to me.
Oh my god.
All right, guys. Hey, deal with your food issues later. Now, real quick, if I wanted to turn around the limits. Oh, sorry. Yeah.
For example, it's kind of like the half of a parabola. Why we don't? I'm confused.
So this right here is this circle here, right?
Well, yeah, the circle is the half of it, but I don't know why we don't need the part that's from 0 to 1/2. Why we need the upper part?
Oh, because it's telling me that x goes from 0 to 1/2. Y goes from what to what?
From X from that.
So he starts here and he goes there. So I know I need inside that.
Oh, okay. If it
Dorito
was
pie.
oh, okay. So that's why we need it. We need to start from there, from the line.
You do what it says, right? It says to start here and go there. So it really isn't as flexible, which is nice. You don't want it to be multiple ways of interpreting it. There's only one way to interpret this. Start at that line, go to that line. That's kind of nice, okay? I'll do that. So then you know you want in here, not down here, for example, right? You know you want in here. So if I were to ask you to turn this around, why would that kind of suck? Can you tell me why it would kind of suck if I asked you to turn this around and go this way?
Because they're both gonna be,
How many integrals would I have to write? 2. Because here it's going from 0. What would x be doing? Going from 0 to
Whatever that is.
x equal 1 over radical 3y, right? And then I have to, at this point, I have to try another integrals. Now it's got to go from 0 to square root of 1 minus y squared. You guys see that?
Yes.
And again, that's another reason to be careful about who said no.
like awesome, the only person.
Yes, don't worry. You're the only person that said it. But